And this is for project number 6, exercise number 6. I already input the data, so next we're going to create the path model. Okay. We're going to input company, okay, like company, and customer demographic. Next, I'm going to rename all the variable. This is for company. Attractiveness. Okay. Next, we're going to connect all the variable. Click connect. Company to attractiveness. Company to customer demographic. Attractiveness. Okay, so before the color is red, and now it changes to blue once it interlinks and connects to one another. The arrow are representing the directional relationship between all the variable. And this diagram that connects the variable to visually display the hypothesis that will be tested in the case. In this case, we can see at the diagram. Next, we're going to calculate PLS algorithm. Click, leave it like that, and start calculation. We're going to make outer links. Oh, so in these outer loadings, all the value must be above 0.7. If there are values below 0.7, it must be deleted. But before that, we have to check our average variance extracted, or the AVE. As we can see, our AVE, there is one AVE that is below than 0.5. And if it is below 0.5, therefore, we must delete 1 or 2 data from the outer loadings. In this case, it's a customer demographic. I go here, we'll delete occupation. Then calculate. Okay, so after we deleted occupation, we'll calculate again. PLS algorithm. Start calculation. We'll check our outer loadings and our AVE. So if our average variance extracted are all in green, which means that everything are above or higher than 0.5, we do not need to delete any more data from here, from their variable. Next, before that, the AVE must be above 0.5 from the confidence interval 95%. And the Cronbach alpha, this one, measure internal consistency. Cronbach alpha and composite reliability is pretty similar, but most likely we only check the composite reliability because it is more precise than the Cronbach alpha. And the higher value indicate higher level of reliability. If it is 0.6 and 0.7, it is acceptable. If it is 0.7 and 0.9, satisfactory or good. Above 0.9, it is considered to be problematic. If reliability value is above 0.95 and above, it means that there is a possibility of an undesirable response between variable. And as we can see here, 0.6 is acceptable, 0.8 satisfactory or good. Everything is satisfactory except for this one. This one is only acceptable. As long as it doesn't, it's not higher than 0.95, it's good. Because 0.95 means problematic. It can be problematic and create an undesirable response between variable. Next, we check our R square. So our R square is 0.065. This one, or 6.5%. It means that from all the variable that we have here, there is 7.4% affected between all the variable. 7.5 affects all the variable. Next, F square. So for the F square, if the F square are below 0.02, it means that there is no effect. If it is equals to 0.02, it has small effect, equals to 0.15, medium effect, and 0 equals to 0.35, it has large effect. This one is in red because it is below than 0.02, which means that it did not have any effect at all. And the other are 0.05, 0.02. It has small to medium effect. Next, we'll check the collinearity statistics. So the value must be between, in this VIF, the value must be between 1 and 3, both in the outer and the inner value. The VIF, or the variance inflation factor, is normally used to evaluate collinearity of the formative indicator, and it should be between 1 to 3 or lower. If it is higher than 5, it indicates a critical collinearity issue among the indicator. In this exercise, all the value are between 1 to 3 except for this one. But besides that, everything are between 1 to 3. So it means that it has good relation, both in the inner and outer. We're going to check the discriminant validity. So in this discriminant validity table, it should be lower than 0.9 or 0.85. And as we can see, all the data are below 0.9, so it's good. It's all good. Okay, next, we'll go back to our path model. We're going to check, we're going to calculate for bootstrapping. Click calculate, bootstrapping, 3,000, because before we have 300 samples and we multiply it by 10 and start. Path coefficient. The p-value in here must be higher than, must be below than 0.5. If it is higher than 0.5, it means that it has no significant effect. In this case, however, we only focus on the data that links to customer demographic. If you take a look at the data, there are only 3 that connects or are linked to customer demographic. So we only focus on these 3. So all the data that are connected to customer demographic are all in red color because it is higher than 0.05. In this case, none of them has any significant effect. Now check outer loadings. Only 2 values, only 2 data that doesn't have any significant effect. Only these 2. But everything else is in green, which is pretty good. And this is for the histogram. Okay, so that is all. Thank you.